Hi, this is Lynn, and I'm going to be doing my presentation on the Seveso dioxin disaster. So to start off with the table of contents, we have the objectives, the timeline, the chemical reaction that occurred to cause the toxic agent, the region of impact, its environmental impact, the health impact, the policy change that occurred after this event, as well as the summary and a list of references. So for our objectives, we have the timeline, which is what led to this dioxin disaster, how did it begin, and how was it resolved. We have the environmental outcomes of dioxin contamination. We want to understand the health consequences that resulted from the exposure, identify what changes in policy occurred, and how the aftermath and cleanup of the contaminants was handled. So this event occurs on July 10th of 1976 when a valve in a chemical plant breaks and releases toxic plumes into the air. This plant was located near the district of Seveso in northern Italy. On July 14th of 1976, the first symptoms of skin lesions occur on children, such as chloroacne, and the death of small animals becomes noticeable in the region of the contamination. On July 17th, the first press articles are released to announce dioxin contamination to the community. It's not until 2 weeks later, on July 23rd, that an evacuation is announced and blood testing begins for those that were exposed. In 1977, a year later, an environmental analysis begins for reclamation of the land. In 1982, there becomes a wide search regarding the missing barrels of toxic waste. These barrels were found to not be disposed of properly, instead buried in a barn in France. So for an overview of the event, on July 10th in 1976 in Meda, Italy, a chemical plant malfunctioned where a reactor valve in the plant opened due to steam pressure. This released chemicals into the air, and one of which is dioxin, TCDD, and wind carried this large plume of dioxin into the town of Seveso and its surrounding areas. Here we have a picture of the region of impact. As you see, the wind was blowing downward, which released the dioxin plume into the region of Seveso, which is located underneath the ICM ESA plant. Dioxin is known to be a persistent organic pollutant, which means it exists for a long time in the environment. It's highly carcinogenic, and it remains in the fatty tissue of animals, so it enters the food chain. It has a long half-life in humans, and this chemical is mostly used for cosmetic and pharmaceutical manufacturing. The chemicals that were released from this particular plant were ethylene glycol, sodium trichlorophenate, sodium hydroxide, and TCDD. Here's a current graph from 2020 of the different sources of dioxin release from the EPA. Most occur from chemical manufacturing. Other dioxin release occurs from the formation of primary metals as well as chemical waste. The data was sourced from the EPA, but I turned it into this pie chart right here. So the environmental impact of the disaster was the increase of animal deaths, specifically rabbits and poultry, and to prevent this TCDD from entering the environment and the food chain, an emergency slaughtering was issued. There was a halt in farming activities. Some long-term environmental impacts were soil contamination and airborne dust that covered the entire area with TCDD, as well as TCDD entering vegetation due to soil contamination, which led farm animals to ingest dioxin-contaminated vegetables. Some of the initial health outcomes that resulted from the dioxin exposure was nausea, headaches, irritation, and skin lesions. More specifically, there were intestinal problems in children. The long-term health effects can be in the increased mortality of cardiovascular and respiratory disease. There are also psychological effects due to the emergency evacuation as well as the political turmoil that this event caused in the area. Moreover, there were gastrointestinal, lymphatic, and topoidic tissue cancer, One of the highest rates of a specific health outcome seen was chloracne, which is a rare skin eruption of blackheads, cysts, and nodules, which is linked directly to dioxin exposure. There's also debate on whether this dioxin exposure can cause an increase in diabetes, which I'll get into later. So here we have a table taken from a study done in 1998, which lists the causes of death of those that were exposed to dioxin from the Seveso incident. On this slide, we have the different causes of death that were deemed significant in comparison to diabetes. Although diabetes is not linked specifically to dioxin exposure, there was a significant increase in the cases of diabetes within the exposed population, as well as this diabetes being a significant cause of death for both male and females. To add on to that, in 2020, there was a study done on the levels of insulin in mice after being exposed to TCDD. It can be seen that the higher the exposure to TCDD over this hour-long period, the less amount of insulin that these mice produced, which is new information regarding the link of TCDD to diabetes. In terms of policy change, the European Community in 1982 passed industrial safety regulations labeled the Seveso Directive. Moreover, Seveso Oak Forest Park was created, which is an area of land neighboring and on top of the plant that caused the exposure. It was covered with dirt and formed into hills. This park is currently off limits, and the plant that caused the exposure remains buried underneath. There was a slew of health monitoring programs as soon as this exposure was noticed. These programs were directed towards those exposed, but also more specifically the workers at ICMESA. There was court conviction of the 5 chemical company officials that were responsible for managing health and safety regulations at ICMESA. On top of that, there were stringent regulations in the processing and manufacturing of chemicals. So to summarize, for the aftermath process, it's important to note that evacuations did not occur until a week after the incident, which prolonged the population's exposure to dioxin, which may have increased the rate of health outcomes noted. This also increased political and social tension in the area and had a large effect on the trust that people had on the government in regulating environmental safety. In the cleanup process, people made sure to wear protective clothing and made note of any chemical residues left over. The chemicals were stored in nuclear waste barrels and were supposed to be disposed of properly, yet they were found to be stored in a barn in France, and not until 10 years later was it incinerated in Switzerland. So these waste barrels of the toxic chemicals were traveling around for quite some time before finally being disposed of. Here I have a table of the distribution of a recovery process in Seveso. This is the type of recovery processes that occurred and the number of times this recovery option has been implemented, the highest being the dismantling and dispose of contaminated material. And lastly, I have my list of references from which all the data was derived.